So guys, welcome to our channel once again. In today's video on our WAEC physics exam revision series, we have here these 10 WAEC repeated questions to answer on the topic electric field. So guys, this video will be about electric current, potential difference, resistance, EMF and internal resistance. So guys, ensure to stay till the end of this video as this is a very important one. So we'll start with the first question here guys, which says when two cells of negligible internal resistance and equal EMF denoted E1 and E2 are connected in parallel, the combined EMF E is given by A, 1 over E is equal to 1 over E1 plus 1 over E2, B, E is equal to E1 and that's equal to E2, C, E is equal to E1 over E2, and then D, E is equal to E1 plus E2. So guys, the answer to this question here is option B, and that's E is equal to E1 and that's equal to E2. So when EMFs are connected in series, the combined EMF is the sum of the EMF of each cell, but then if it is connected in parallel, then the combined EMF is same as the EMF of one of the cells. So that will be in the manner shown here in option B. So that's it for this question. Let's go ahead and consider the next question guys. So that's question number 2 here guys, and the question here says calculate the internal potential difference across a 2 ohm resistor connected to a battery of EMF 15 volts and internal resistance 5 ohms. So guys, for this calculation we are to calculate for the terminal potential difference. So we are given the internal resistance R to be 5, and then the resistance here is actually 20 ohms, and then the EMF of this cell is actually 15 volts, and we are looking for the potential difference. So let's recall that potential difference is equal to IR, but then let's calculate this. Let's say E is equal to I into R plus R. So with this we can first get the current, and then from the current we can now get the potential difference, since the potential difference volts in volts is equal to IR. So in this case here, if we make I the subject of this equation, we are going to have that I is equal to E over R plus R. So where E is already 15 volts, and then R here is 20 ohms, then plus R here, the internal resistance, which is 5 volts. So this will be 15 over 25, and guys, that's 0.6 amps. So now that we've gotten the current, let's go ahead and wipe this, and then let's solve for the potential difference, which is in volts, and this will be IR. So in order to get the potential difference, we'll substitute everything, we'll replace everything by their values. So when we plug in the value of I, which is 0.6 here, multiply that by this resistance here, which is 20. So the potential difference in volts is equal to 0.6 times 20, and this will be 12 volts here. And that's it for this question. Option D is the answer to this question. So let's go ahead and wipe this here, and then let's consider the next question. So guys, the next question we have here is question number 3 here. It says a cell of EMF 2 volts has an internal resistance of 0.5 ohms. A current of 0.4 amperes passes through an external resistor P. Determine the resistance of P. So guys, for us to solve this, we'll still go ahead and plug in our formula here. So for our formula, E is equal to I into this. So for this, E is given in the question as 2 volts, and then I, which is the current here, is given as 0.4 ampere. Then the R here is not given, but then the internal resistance is given, which is 0.5. So for this, we'll have to make R the subject of this equation. But then in order to make R the subject of this equation, we can write this to be R plus 0.5 is equal to 2 over 0.4. So now that we've gotten to this level, if R plus 0.5 is this, we can now get R. So R now becomes 2 over 0.4 minus 0.5. If we calculate for 2 over 0.4, we'll have 5. So in that case, R is equal to 5 minus 0.5, and that's 4.5 here. So R is equal to 4.5 ohms, and that's option A here, guys. So that's the answer to this question. Let's go ahead and consider the next question, guys. So guys, that's question number 4 here, and the question here says 2 identical cells, each of EMF 2 volts and internal resistance 1.0, are connected in parallel. The combination is connected to an external load of 1.5 ohms. Calculate the current in the circuit. So guys, actually, since we have this connection in parallel, the effective EMF of this connection will still be 2 volts, and then the external resistance here already is given to be 1.5. So we want to calculate for the current. So guys, since this connection is in parallel as well, in order for us to get the effective internal resistance, that will be 1 over R plus R. That's 1 over 1 plus 1, and that's 1 over 2. So effective internal resistance is 1 over 2. Okay, so now that we've gotten this, we know that E is equal to I into R plus R. So I here will be E over R plus R. But then for E, since this is a parallel connection, the effective EMF here will still be 2. So whereas for R here, we'll have 1.5, that's the external resistance, and then plus 1 over 2 is 0.5 here. So the current now will now be 2 over 2, and that's 1, guys. So the current here is 1 amp, and that's it for this question. Let's go ahead and wipe this, and then let's consider the next question. So guys, the next question here is question number 5 here. It says, which of the following factors does not affect the EMF of a primary cell? It's A, internal resistance, B, size, C, duration of usage, D, operating temperature. So guys, the answer to this question is option B, and that's size. So let's go ahead and consider the next question. That's question number 6 here. It says a cell of EMF 1.5 volts and internal resistance 1.0 ohm is connected to two resistors of resistance 2.0 ohm and 3.0 ohm in series. Calculate through the resistors. So guys, for this question here, we're going to solve together here. So given that the EMF of this cell is 1.5, and then the internal resistance is 1.0 ohms, and then the load resistance is 2.0 ohms, and then we have the load resistance 1, that's the first load resistance, and then we have the second load resistance here, because we have two resistors here. So that's this and this. So we also have load resistance 2, which is 3.0. So actually what we are meant to calculate here is the current, because actually here in your options you have seen these, so the question is not so clear. This should be calculate the current through the resistors. So in order for us to calculate the current here, we are going to actually first of all solve for the effective load resistance here. So that will be R1 plus R2. So since the resistors are connected in series here, so that will be 2 plus 3, which is 5. And then now that we've gotten the resistors, so we already know that E is equal to I to this. So in order for us to calculate for the current here, it's going to be E over R plus R, where E is 1.5, and then R here is 5, and then the internal resistance here is 1. So in that case, I is going to be 1.5 over 6. So 1.5 over 6, and that's 0.25 amps. That's option A here, guys, and that's the answer to this question. So let's wipe this off and let's consider the next question. So that's question number 7 here. It says a chemical cell of internal resistance 1 ohm supplies electric current to an external resistor of resistance 3 ohms. Calculate the efficiency of the cell. So guys, in order for us to calculate for the efficiency, we can use the formula load resistance over load resistance plus internal resistance, all multiplied by 100%. So in this case, let's go ahead and solve this together. So the efficiency is going to be load resistance, which is the external resistance here, that's 3, over load resistance again, which is the external resistance, which is 3, then this plus the internal resistance, which is 1 here, then whatever it is times 100%. So this will be 3 over 4 here. So 3 over 4 is 0.75 times 100%, and this will be 75%, and that's option B here, guys. Option B is the answer to this question. So let's swipe this off and let's go ahead and consider the next question, guys. So that's question number 8 here, and the question says, which of the following statements explains lost volts in an electric circuit? The A, total potential difference from a source to maintain a flow of current through the circuit as well as the source. B, potential difference across the internal resistance of the cell. C, potential difference all external components connected to the source of electricity. D, potential difference to drive current through the circuit components except the source. So let's recall the question says, which of the following statements explains lost volts in an electric circuit? So guys, lost volts in an electric circuit refers to the potential difference across the internal resistance of the cell. So this is because when the current flows through the circuit, some energy is lost as heat due to the internal resistance of the cell. So this energy that is lost is represented as lost volts. And guys, the answer to this question based on this is option B, the potential difference across the internal resistance of the cell. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 9 here, guys. Question number 9 says, a cell of EMF 1.5 volts is connected in series with a resistor of resistance 3 ohm. A high resistance voltmeter connected across the cell registers only 0.9 volts. Calculate the internal resistance of the cell. So guys, for this, in order for us to calculate this, let's first of all look for the current here, and let's use V is equal to IR. And with this, if we make I the subject of this equation, I will be V over R. So in this case, our voltage here read from this is 0.9, and then the resistance is actually 3. So when we divide this, we'll have 0.3. So this is 0.3 amps. So now that we've gotten this, the E, like we already know, is this. So if E is this, then in order for us to find the internal resistance, we have to open this bracket. So E now becomes IR plus IR. So for this, we can actually have IR to be E minus IR. So R alone now becomes E minus IR over I. So here now we can plug in the values and then solve for this. But then, since V is equal to IR, we can actually replace this with V. So in this case, we are going to have R is equal to E minus V over I. So in this case, we are going to have R to be E is 1.5. So 1.5 minus the voltage 0.9, and then this will be over the I, which is 0.3. And guys, from this, the answer to this question is 2.0 ohms. So that's it for this question, and that's option D here. So that's the answer to this question. Let's go ahead and wipe this off, and let's consider the next question, guys. So that's the last question for this video. So that's question number 10 here. It says a cell of EMF 1.5 volts is connected in series with a resistor of resistance 3 ohms. A high resistance voltmeter connected across the cell registers only 0.9. Calculate the... Okay, guys, this is just the same question we just answered previously. That's 2.0 ohms, and that's the answer to this question. So this is where we end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community, where we post major updates on WAEC examination. So guys, this will help you a lot even as you prepare for your WAEC examination for the year. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.